Hi, this is Jaydeep Sai, and the topic which I have selected for this TikTok video is opportunities and challenges of software defined mobile networks in network security. Let's discuss the introduction of the topic. Mobile network operators are facing challenges due to the rapid growth in data traffic, particularly from the high number of smartphones and sophisticated network services. Today's mobile networks support various network services such as voice over IP, high density video streaming, internet TV, electronic payments, and mobile cloud services. Therefore, mobile operators now compete with a new class of competitors, including the over the top players, cloud operators, and established internet service providers, which are called as ISP gains. Thus, mobile operators must roll out new network services and applications rapidly to maintain a competitive edge. They also need to improve performance at a lower operational cost to provide high quality services for attractive prices. So, the mobile network operators are facing challenges due to the rapid growth in data traffic. So, in the data traffic, where the large amount of data is generated, particularly from the high number of smartphones. So, from the high number of the smartphones, where the smartphones are used in a large number by so many sophisticated people and also by the common people, and also some of the network services. Today's mobile networks support various network services. So, we can see that today's mobile networks support various types of network services, such as voice over IP. IP is Internet Protocol and high density video streaming. So the mobile phones can also provide high density video streaming, internet TV, electronic payments. So we can pay using electronic payments and mobile cloud inter services. Therefore, mobile operators now compete with a new class of competitors, including over the top players, cloud operators, and established internet service provider gain. Thus, mobile operators must roll out new network services and applications rapidly to maintain a competitive edge. They also need to improve performance at the lower operational cost to provide high quality services for attractive prices. However, legacy mobile networks often struggle with limitations such as stationary and expensive equipment, complex control protocols, and configuration interfaces, which hinder the development of telecommunication networks. So, the legacy mobile networks often struggle with limitations such as stationary and expensive equipment. The mobile networks have the expensive equipment for building the mobile networks and also stationary equipments. So the stationary equipments are can't movable and it should be placed at only one place. So it makes the problems and these are the limitations for mobile networks and the complex control protocols and configuration interfaces which hinder the development of telecommunications networks. In this context, software defined network SDN network functions, virtualizing NFV, and cloud computing principles are promising technologies that might address the limitations in legacy mobile networks. Software-defined mobile network and architecture integrates these technologies in mobile network environment, securing only the perimeter. Today's telecommunications networks heavily rely on perimeter security mechanisms. 5,6 mobile network edges interfacing to external networks are considered the most vulnerable points in the network and are protected by intrusion prevention systems, which are called as IPS, not the Indian Police Services, but intrusion prevention systems, firewalls, customer edge switches, CES, carrier grade network, address translators, NATS, and so on. Distributed and uncoordinated security mechanisms. A diverse set of security mechanisms is developed on different sections of mobile network. For instance, LTE networks use radio network layer encryption for radio access network and internet protocol security, which is IPS-EC encryption for backhaul network. The security mechanisms work autonomously with limited awareness of other devices. So this is about the distributed and uncoordinated security mechanisms. Telecommunications networks should also support backward compatibility for old access technologies. Today's telecommunications networks support a diverse set of wireless technologies, including general packet radio service, enhanced data rates for GSM, global system for mobile communications, evolution, wideband, code division, multiple access, LTE and Wi-Fi. Each wireless technology uses independent security mechanisms and policies, so the telecommunication network should also support backward compatibility for old access technologies. So for the old access technologies, the telecommunication network should also support backward compatibilities. Today's telecommunication network support a diverse set of wireless technologies. So the telecommunication network supports a diverse range of wireless technologies, including the general packet radio service GPRS, enhanced data rates of GSM global system for mobile communications evolution, wideband code division multiple access, which is WCDMA, LTE and Wi-Fi. Each wireless technology uses independent security mechanisms and policies tightly coupled to physical resources. So here is about the tightly coupled to physical resources, security policies and mechanisms in present day mobile networks are tightly coupled to physical resources such as switch ports and interfaces rather than to network services and user applications. Such policies were sufficient for legal legacy telecommunications networks because they supported mainly voice and text message services. However, today's telecommunication networks offer advanced network services such as mobile banking, e-health applications, mobile payments, email, and secure web browsing. So these are the services such as advanced network services such as mobile banking, e-health applications, mobile payments, email, and securing web browsing. These are the tightly coupled to physical resources which are the services which are provided by the mobile communication devices and the mobile telecommunications networks at the present age. Lack of adaptation. Current mobile networks mostly use reactive security mechanisms and can't make real-time decisions rapidly and collaboratively. In other words, it's challenging to dynamically adjust the security policies quickly by monitoring and detecting abnormal behaviors or malicious events in a mobile network with thousands of backhaul nodes. So the current mobile networks mostly use reactive security mechanisms and can't make real-time decisions rapidly and collaboratively. In other words, it's challenging to dynamically adjust the security policies quickly by monitoring and detecting abnormal behavior or malicious events in a mobile network with thousands of backhaul nodes. Moreover, most security mechanisms are static and tightly coupled with devices. Such security policies can't be changed without resetting or replacing the whole device. Or provisional security mechanisms in current telecommunication networks are designed to handle the heaviest traffic loads. Service disruptions are avoided by oversizing the network capacity and overpopulating the resources for security mechanism. Therefore, most security resources are underutilized for a long period of time. Furthermore, mobile networks support backward compatibility and interoperability to maintain different generations of technologies such as 2G, 3G, 4G, Wi-Fi, and WiMAX. So these are the services which are backward compatibility and interoperability to maintain different generations of technologies. So the technologies include 2G, 3G, 4G, Wi-Fi, and WiMAX. Vulnerability to IP-based attacks. So Internet protocol-based attacks and showing the vulnerability to them. Recent IP-based mobile networks, for instance, LTE and LTE Advanced, are vulnerable to security attacks such as distributed denial of service, DDoS, insider attacks, botnets, and other IP-based attacks. Those attacks are common in telecommunications networks. More than 90% of mobile operators experience DDoS attacks. In 2012, unprotected and always on devices such as smartphones and tablets are great platforms for attackers to launch DDoS. For instance, attackers can deploy a botnet on smartphone to carry other DDoS attacks on a mobile network with the same multi-access, multi-operator environment. Mobile networks maintain backward compatibility and interoperability to support different generations of technologies. For instance, 2G, 3G, 4G, and LTE advanced. Moreover, a telecommunications network's operational environment consists of different operators. The operators such as capacity providers, virtual operators, and ISPs. This leads to complex security policy negotiation processes, privacy concerns, and potential policy conflicts. Therefore, enforcing security in today's telecommunication network is a challenge. Most telecommunications operators use independent and separate security mechanisms and policies for each technology and operator. Dynamic attack mitigation. The dynamic attack mitigation, so yes, network security personnel can leverage a centralized controller to monitor network activity and use it to detect anomalous behavior and mitigate it with high accuracy. For instance, malicious traffic generated by an attack can be blocked as early as possible. For instance, the wireless edge for mobile-based DDoS attacks rather than allowing it to reach the core network switches. Moreover, holistic network informatics are used and efficient for forensics. Visualized middle boxes. The operator has the flexibility to simplify the DP devices by integrating their functionality in the SDSM network controller. Therefore, traditional middle boxes such as CES, NAT, and firewall can be implemented in virtualized resources. This reduces the complexity and cost of security devices. Economically viable SDMN architecture significantly reduces the resources required for security by optimizing resources and implementing middle boxes in virtual environments. It eliminates the need for complex and expensive security devices in the network and decreases capital expenditure network costs. In addition, adaptation of the SDMN concepts offer flexible management, dynamic countermeasures, and automatic configuration, reducing operation expenses. Moreover, these security mechanisms can be automatically executed, significantly reducing human efforts. I thank the faculty and the college for providing me this opportunity to speak on the topic in this TikTok video. Thank you.